Hello, and a very warm welcome to everyone joining me today. I am truly happy you're here. Before we jump into one of the most astonishing and fundamental truths of our universe, I want to take a quick moment to send my very best wishes to you and your loved ones. Wherever you are in the world, I genuinely hope you are happy, healthy, and feeling great. Now, prepare to have everything you think you know about speed, space, and reality completely turned upside down, because we are talking about the one rule in the universe that absolutely nobody is allowed to break. We all understand speed intuitively. If you're sitting in a car going 60 miles per hour and you throw a baseball forward at 20 miles per hour, someone standing on the side of the road will see that baseball moving at 80 miles per hour. The speeds add up. It makes perfect sense. If you were in a plane going 500 miles per hour and you started walking forward towards the cockpit at 3 miles per hour, your speed relative to the ground would be 503 miles per hour. This is how everything in our daily lives works. It seems so obvious and undeniable that we never even question it. So, let's apply the same logic to light. Imagine you are in a spaceship that can travel incredibly fast, let's say at half the speed of light. You turn on the spaceship's headlights. Common sense tells us that the light from those headlights should now be racing away from your spaceship at the speed of light plus your spaceship speed. If you're going half the speed of light, the light should be going 1.5 times the speed of light from the perspective of someone watching you zoom by. This seems like the most basic math in the world. But it is wrong. Completely, utterly, and provably wrong. Here is the simple, universe-altering fact. The speed of light in a vacuum is always the same for everyone, no matter how fast you are moving or in what direction. It is a universal constant. That number is 299,792,458 meters per second. It doesn't matter if you are standing completely still on Earth, or flying in a super-fast spaceship towards the light source, or away from it. Every single observer, in any state of motion, will measure that beam of light to be moving at exactly that same speed, 299,792,458 meters per second. It doesn't add. It doesn't subtract. It is the ultimate cosmic speed limit, and it is the same for everyone. This isn't a theory, it is a law of nature, and it was the brilliant insight that led a young patent clerk named Albert Einstein to develop his theory of special relativity. This idea is so weird that it feels like it must be a trick. How can everyone measure the same speed? Let's go back to our spaceship example. You are in your spaceship moving at half the speed of light. You turn on your headlights. From your perspective inside the ship, everything is normal. You see the light beam zip away from you at the full speed of light. Now, imagine I am standing on a nearby planet, watching you fly past me. I also measure the light beam from your headlights. And according to this rule, I also measure it moving away from me at the full speed of light, not any faster. How on earth can that be? If the speed is the same for both of us, but we are moving relative to each other, something else has to give. That something else is the very fabric of reality itself. Time and space. The universe, in order to keep the speed of light constant for all observers, is forced to bend and stretch time and distance. This is where things get truly mind-bending. For the math to work out, for both of us to measure the exact same speed for that light beam, time itself must slow down for you on the moving spaceship from my perspective. This effect is called time dilation. Your clocks, your watch, even the very biological processes of your body, would appear to me to be ticking slower than my own. From your perspective inside the spaceship, you wouldn't feel anything strange. Your time would feel perfectly normal. But if we could compare clocks after your journey, we would find that less time had passed for you than had passed for me. You would have, in a very real sense, traveled into the future relative to me. Simultaneously, space itself must contract. From my perspective on the planet, your fast-moving spaceship would appear to be shorter, squished in the direction of its motion. This is called length contraction. So, the reason we both measure the same speed of light is that your measurements of time and distance are different from mine. The universe adjusts the very rules of measurement to keep that speed constant. This isn't just a wild idea, we have proven it beyond any shadow of a doubt. We see it in particle accelerators every single day. Scientists take subatomic particles called muons, which are created in the upper atmosphere and have very short lifespans. They decay so quickly that even traveling at nearly the speed of light, they shouldn't make it more than a few hundred meters before vanishing. Yet, we detect them all the time at the Earth's surface. Why? Because from our perspective on Earth, time for the fast-moving muons is dramatically dilated. Their internal clocks are running so slowly that, from our point of view, they live long enough to complete the journey. From the muon's perspective, its lifetime is normal, but the distance to the Earth's surface has contracted, making the trip much shorter. Both perspectives are correct, and they only make sense because the speed of light is the fixed point that everything else must bend around. This constant speed of light is the foundation of much of modern physics. It is the C in Einstein's most famous equation, E equals mc squared, which shows that mass and energy are two forms of the same thing. It is the reason why nothing with mass can ever actually reach the speed of light. The closer you get to light speed, the more your mass effectively increases, requiring more and more infinite energy to accelerate further. Light itself can travel at this speed because it is made of photons, which are massless particles. This rule also means that when we look out at the stars, we are looking back in time. The light from our sun takes about 8 minutes to reach us. The light from the next nearest star, Proxima Centauri, takes over 4 years. When we look at it, we are seeing what it looked like 4 years ago. The light from the Andromeda galaxy is 2.5 million years old. The speed of light is the ultimate speed of causality, the speed at which information can travel through the universe. It is the thread that connects the past to the present for our eyes. So, the next time you flip a light switch, remember that the light flooding the room isn't just illuminating your space. It is a messenger obeying the most fundamental and unbreakable rule of the cosmos. It is a constant reminder that the universe is far stranger, more mysterious, and more wonderful than our everyday experiences suggest. Our common-sense notions of speed and motion are just a local approximation, a small-town rule that doesn't apply on the cosmic highway. Out there, the only rule that matters for light is that everyone, everywhere, must agree on how fast it's going. Thanks for joining me on this journey into the heart of physics. Take care, stay curious, and I'll see you in the next one.